Okay, in this next video, we're going to look at how we can use this new conversion between grams and moles. And I'm going to do 4 examples. 2 examples just using a single elements, and then I'm going to do 2 that involve compounds. Those don't change much, except you have an extra step where you have to do some addition. But they're really easy once you see how it's done. So follow along. If I have 0.0536 grams of magnesium, how many moles does that represent? Well, we go to our periodic table and we see that this 24.31 represents 2 different things. For us, it represents that 1 mole of magnesium is equal to 24.31 grams of magnesium. This is where you are beginning your long journey of making the conversion factors that you need to solve a problem without having a list of them sitting in front of you. In fact, all of the conversions that you are going to do for the rest of the year, for the most part, are going to come either from the periodic table or later from a chemical reaction that you write out. So, always have your periodic table sitting in front of you. I would also tell you to use the periodic table I gave you so that everybody is consistent in the conversions when we're using those masses. So let's look at the setup. Pretty straightforward. Start off with the unit that we are converting to 0.0536 grams of magnesium times blank. Grams of magnesium on the bottom. Periodic table has our conversion for grams. So we say 24.31 grams of magnesium. And that's going to be equal to, as we saw from our last video, 1 mole of magnesium. Keep in mind, I'm going to start using the MOL abbreviation because that's what I'm used to. In fact, I'm going to put up on the board and just say 1 mole of whatever. Insert your atoms, insert your compound, whatever formula you have there is going to equal grams of whatever it is that you're talking about. So mole of magnesium in this case is going to equal 24.31 grams of magnesium. You simply just insert what you need to. If this were 1 mole of carbon, we'd have 12.01 grams of carbon. And then we solve that out. So we're going to have 0.536 divided by 24.31. We use this number to determine our significant digits. Your calculator is going to give you 2.20 times 10 to the negative second. 2.20 times 10 to the negative second moles of magnesium. Okay, next question. So our next question is, if we have 25.8 moles of oxygen, how many grams of oxygen do we have? Same setup. Hopefully these conversions are you're getting pretty used to those. 25.8, because the setup of these is the same. It doesn't matter what units they are. Even though this is a new unit, the setup of our conversion is the same. So 25.8 moles of oxygen times blank. Moles of oxygen. That's our automatic step. I know you're not familiar with this, but this is going to become so second nature to you. We're trying to get to grams, and we have a conversion from grams to moles off the periodic table. Except for oxygen, if you look at the periodic table, it says 16. So that means if I have 1 mole of oxygen, I'm going to have 16.00 grams of oxygen. That's it. Calculate that out. 25.8 times 16, and we're going to get 4.13 times 10 to the second grams of oxygen. That means, or on your calculator it came out 4.128, but since we only need 3 significant digits, we dropped that 8 and rounded up to 3. Let's do another one. This time we're going to use a compound. Okay, in this one, we have a compound, but the same setup is going to be used. We just have one extra step that we're going to need to do. So we're going to start off 253.6 grams of potassium chromate. Now we got a problem, but it's not a real big problem. There is no potassium chromate on the periodic table. Potassium chromate is made up of 3 different elements. But the basic idea in how the periodic table works is that we can get that mass in grams for 1 mole of potassium chromate by simply adding up all the different parts that make up that compound. So here I have listed the masses of each of the elements. So this is for the potassium, this is for the chromium, and this is for the oxygen. The formula tells you how much of each element is in them. So we would have 39.10 times 2, because there's 2 potassiums. We would have 52.00 times 1, and then we would have 16.00 times 4. Let's do the easy math. That's going to be 64. This is going to be 52. And I got to pull out a calculator for the 39.10 times 2. It's going to be 78.2. If we add those up now, we're going to get 194.20 for our mass, and that is what we would enter here for our mass of potassium chromate. Nothing drastic. All you have to do is look at the formula. Add up the formulas off the periodic table, making sure that you multiply by whatever the subscripts are for each one of those. And when we calculate this out, you get 1.306, because it's a 5, but it rounds up when you drop, times 10 to the 0, so we're just going to leave it at 1.306 moles of potassium chromate. Let's do one more. Okay, in our last example, we're going to convert 3.8 times 10 to the -4th moles of aluminum carbonate, and we're going to convert that into grams. I included a compound that involved parentheses so you can see an example of this. This is something you will commonly see. But again, if you understand basic math, you're going to be just fine with this. So, as we start off with every conversion, write out what it is you are converting. 3.8 times 10 to the -4th moles of aluminum carbonate. Moles are going to go in the bottom. And we know that on the periodic table, the masses represent 1 mole to grams. So I'm going to have 1 mole, I'm going to have grams of aluminum carbonate on the top. we need to figure out what this is. So, as you saw in the previous example, we just simply add up all the masses and multiply them by however many atoms we have. So the first one's easy. We've got aluminum has a mass of 26.98 on the periodic table, and there are 2 of them. So that's for my aluminum. And if I take my carbon, we know on the periodic table it's 12.01 times, now this is where you've got to be careful and aware. This 3 is outside the parentheses and represents that there are 3 different carbonate ions as part of this compound. So it's kind of like in math where this 3 outside of the parentheses distributes through and multiplies all of these by 3. It only, though, applies to those things that are in the parentheses, not to the aluminum. So it's written to the lower right, it applies to this only. So we have 3 carbon atoms, so we're going to have 12.01 times 3. And then for the oxygen, we're going to have 16.00 times this 3 multiplies this 3 in here, so we're going to have 9 oxygen atoms. And when we add all those up, we get 233.99 and that's the mass that we would put in here, 233.99 grams. Calculate it out. And you get 8.9. On your calculator, it comes to 8.891. So we only need 2 significant digits. So we're dropping the 9. It rounds it up. That rounds that 8 up to 9 times 10 to the -2 grams of aluminum carbonate. So this is your first taste of gram to mole conversions using elements and compounds. Relatively straightforward.